Hello everyone to the Pencil Tutors channel. I'm Anis and today I will be teaching you about Form 5 Chapter 2 Matrices. Let's get into it. A matrix is a set of numbers arranged in rows and columns. To form a rectangular or square array. So how I remember rows and columns is rows is horizontal and columns is vertical. So how I remember it is like Ultraman kind of. So Ultraman he goes like this and then like this, right? His arms go like this and this. So the flat one is rows and then the one that goes up is columns. Matrix is usually represented with a capital letter and written in brackets like this or like this, but it's usually written in this bracket. If you are given a data like this, then the way to write a matrix from this data is you just copy paste what you see. So you can go like this. So I just copy paste what I see. So I just go like this: 15, 10, and 8. So now this is called a row matrix because it only has one row. This is the row, only one row. This is columns. But we can also write it like this: 15, 10, 8. Instead of going horizontal, you go vertical. This is called a column matrix because it only has one column. See, just one column, but it has 3 rows. So when I see data like this, I usually want to copy paste how I see the data because it's much easier. But if the question asks you specifically how you have to write it, then you have to follow through with the question. Alright. Now, let's look at square matrices. Square matrices is when the number of rows is equal to the number of columns. Okay, the table shows students who won in their school sports in their house teams. So how I write this data into a matrix form is like this. So I just copy paste how I see it. There you go, 2, 0, 1, 1, 3, 4, 2, 1, 0, 1, 2, 3. I have to raise this bit. 1, 2, 1. 1, 2. Close that. So you see here, the number of rows is the same as the number of columns, 3, 4. But we can also change the placing a little bit. We can also write it like this. Instead of going vertical like this, we can make it horizontal. So we write it like this. So 2, 3, 0, 1, 0, 4, 1, 2, 1, 2, 2, 1, 1, 1, 3, 2. And change it like that. So here, in this matrix form, the columns are the house colors and the rows are the sports events. In this matrix form, the rows are the sport teams and the columns are the sport events. So that's why I see when you see a data, it's easier to just copy paste. But if the question is specifically, you have to write it specifically, then you have to write specifically. You have to follow the question. Okay, but what if the question doesn't give you in a data form? It gives you in a written form like this. So look at the question. In test 2, Syed scored 70 marks for Bahasa Melayu, 82 marks for maths, and 72 marks for history. Hamid scores 80 for Bahasa Melayu, 88 for maths, and 70 for history. So look at here. We have Syed and Hamid. So these two can either be 2 rows or 2 columns. And then we look at the marks here. We have 76, we have 82, and we have 72. And we have 80, 88, and 70. So these marks can either be written in columns or can either be written in rows. Okay, so let's try writing this information into a matrix form. So we have two ways to write: 2 rows, or 2 rows, 3 columns, or 3 rows and 2 columns. So let's write here: 76, 82, and 72. Then we have for Hamid, 80, 88, 70. Or we can write it like this: 76, 82, 72, 80, 88, 70. So the rows in this one represent Syed and Hamid, and the columns represent the marks. But for this one, the rows represent the marks, and the columns represent Syed and Hamid. So this one, you see how the rows and columns are different. Now this one is called rectangular matrices. Rectangular matrices have different rows and columns. So you've learned 4 matrices: row matrix, column matrix, square matrix, and now you've learned rectangular matrix. Okay, now if you are given a question like this, what I like to do is I like to imagine it's in a data form, and either I copy paste or I switch it up a little following the question. Alright, easy enough, right? There's always 2 ways on how you can write it. You can either write it horizontally, or you can write it vertically. There's no space here. Yeah. So you can either write it horizontally like this, or you can write it vertically like this. But when I have a question like this, what I like to do is I like to imagine it's in a data form, so I know how to write the matrix form of it. Now let's look at order matrix. Order matrix is determined by counting the number of rows followed by the number of columns. So this matrix has 2 rows, 1, 2, and 3 columns, 1, 2, 3. It is a matrix with order of 2 by 3. Or we can write it as matrix 2 by 3. The row always comes before the column. Okay, row comes before column. Alright. Okay, every number in this matrix is known as element. Everything in this matrix is known as element. For example, if I wanted to know the element of the second row and third column, how do I find that? So what I do is I simply look at the second row here, and then the third column. So do you see that this one overlaps with the 2? So when I look at the second row and third column, the element is 14. Okay, and a capital letter is used to denote a matrix. So a capital letter, let's say I want to use A. So A denotes the matrix 16, 18, 11, 5, 10, 14. So the element just now, the one at the second row and third column, we can represent it as A, because the matrix is A, 2, 3. So the element at A, 2, 3 is 14. So in general, the element at the ith row and jth column in matrix A can be represented as this. I represents row and J represents column. But what if I want other capital letters like P, Q, R? So then the elements that we want to represent, just put it in lowercase and then put the rows and columns that we want. So as I said, I represents row, J represents column. So if the matrix is P, then I want to find, let's say, element 3, 1. So I look at the third row and the first column. Okay, just like this. Say the matrix is R, like R 5, 4, 1, 3. This is matrix R, and I want to find element in matrix R 1, 1. Then I look at the first row and the first column, which is 5. So it's 5. Alright? Okay, let's look at these questions. I have matrix B and matrix C. The question asks, what is the order of each matrix? So let's change our pen color here. So the order of matrix B, is, let's see how many rows. 1, 2, 3. Okay, 3. 3 by how much? There's 2. 1, 2. 3 by 2. Okay, that is the order of matrix B. So what about matrix C? Order of matrix C is how many rows? 1, 2. 2 rows. How many columns? 1, 2, 3. 3 columns. Okay, find me element B12, B22, C22, and C13. So B12. So row 1 and column 2. So it's 10. The element at B12 is 10. So B22, second row, the second column. So it's for C22. C22. So C22, let's see. Second row, okay, second row here. Second column. So it's 30. Okay, and C13. C13. Okay, C13 is the first row, and the third column is 60. Okay, easy enough, right, guys? You can do it. Equal matrices. Matrices can only be equal if and only if both matrices have the same order and corresponding elements are equal. Okay, for example, I have matrix M and matrix N. So let's see, do they have the same order? M is 2 by 2 and N is also 2 by 2. Yes, they have the same order. Now let's see at the corresponding elements. So corresponding elements is when one element equals the other. So A corresponds with 1. So okay. C corresponds with, wait, hold on, let's go B. B corresponds with 3. Okay. C corresponds with 2. Look at the placement. 2. And D corresponds with 4. So yes, the corresponding elements does equal each other. So when it equals each other, we can write it as M equals to N. Okay. I'll highlight this. When they have the same order and when the elements correspond with each other, then it can be written as M equals to N. Alright? So let's see here. Does matrix C equals to matrix D? Look at the order. Look at the order. The order here is 1 by 2. And this one is 2 by 1. The row are not equals. The column is also not the same. So therefore, no, these are not equal. Because they do not have the same order. Matrix C has order of 1 by 2, and matrix D has order of 2 by 1. Okay. Be careful when answering questions. Look at it properly. Rows and columns need to be the same for it to be equal. Okay. Because from there, let's say we have a question like this. Matrix P and matrix Q. Find X, Y, and Z if P equals to Q. P does equals to Q. Look at here. This has 2 rows and 2 columns. This one also has 2 rows and 2 columns. So this one is both 2 by 2. So find X, Y, and Z. So X, the corresponding element is 5. So X equals to 5. Let's look at Y. Okay, Y, corresponding element is 7. So Y plus 1 equals to 7. Y equals to 6. And let's look at Z. So Z, corresponding elements. So 5 minus 3Z equals to 2Z. 5 equals to 5Z. Z equals to 1. Okay? Easy enough, right? It's not hard. You can do this. Thanks for watching part 1. Be sure to check out part 2 in the next video on basic operation on matrices. Don't forget to subscribe and bye!